A 150 amp electrical panel with additional spaces will be required. The ground fault circuit interrupter GFCI SPA panel will be needed, in addition to 3 number 8 THHN/THWN copper wires for the hot tub and 1 number 10 THHN/THWN copper wire for the ground for the hot tub. You will also need 2 number 12 THHN/THWN copper wires for the shed circuit for the washing machine and general use receptacles. Conduit for burying the wires is also needed. Electrical boxes, covers, and fittings will be required. Finally, concrete or other material for securing the pedestal mount panel may be necessary. The labor portion of the project includes removing the existing 150 amp panel and installing a new one with more spaces. Mounting the GFCI SPA panel is included in this step. Running conduit and pulling wires from the panel to the hot tub is necessary, as well as running conduit and pulling wires from the panel to the shed. The next steps involve installing the electrical boxes, covers, and fittings. Finally, connecting the wires and securing everything. The materials may cost between $500 and $700, while the labor could range from $500 to $700 as well. The total estimated cost for the project is $1,000 to $1,400. The permit costs $35. Wires should be buried at least 18 inches deep to meet code requirements. A disconnect switch is recommended for the hot tub circuit. It is essential to follow all electrical codes and consult with a qualified electrician if you are unsure about any aspect of the work. The actual cost may vary depending on your specific location, the materials used, and the complexity of the installation. When selecting a new electrical panel, ensure it has sufficient spaces for all planned circuits, including the hot tub, shed, and any future additions. Consider a panel with at least 20 spaces to provide ample room for expansion. The new panel should be rated for at least 150 amps to match the existing service. Prior to any work, de-energize the existing panel by turning off the main breaker. Verify that the power is off using a non-contact voltage tester before proceeding with the removal. Carefully disconnect all existing wiring from the old panel, labeling each wire with its corresponding breaker number to ensure proper reconnection to the new panel. Mount the new panel securely to the pedestal, ensuring it is level and properly aligned. Transfer the existing breakers from the old panel to the new panel or install new breakers of the appropriate amperage for each circuit. Connect the labeled wires to the corresponding breakers in the new panel, ensuring each connection is tight and secure. Connect the neutral and ground wires to the neutral and ground bars in the new panel, respectively. Double-check all connections to ensure they are properly tightened. Install the panel cover and turn on the main breaker to energize the new panel. Test each breaker to ensure it is functioning correctly. Mount the GFCI SPA panel near the hot tub, following the manufacturer's instructions and local electrical codes. The GFCI SPA panel is designed to protect against electrical shock hazards associated with hot tubs. It provides a local disconnect and GFCI protection for the hot tub circuit. Connect the wires from the main panel to the GFCI SPA panel, ensuring proper polarity and secure connections. Connect the wires from the GFCI SPA panel to the hot tub, following the hot tub manufacturer's wiring diagram. Test the GFCI SPA panel to ensure it is functioning correctly by pressing the test button and verifying that the circuit trips. Bury the conduit for the hot tub and shed circuits at a minimum depth of 18 inches to comply with the National Electrical Code (NEC). This depth protects the wiring from physical damage and ensures it is not exposed to the elements. Use Schedule 40 polyvinyl chloride (PVC) conduit for underground wiring, as it is durable and resistant to corrosion. Consider using rigid metal conduit (RMC) for added protection in areas subject to heavy traffic or potential damage. When running the conduit, avoid sharp bends or kinks that could damage the wiring. Use conduit sweeps or bending tools to create smooth, gradual bends. Install pull boxes or junction boxes at regular intervals along the conduit run to facilitate wire pulling. The number 8 copper conductors are rated for 40 amps at 75 degrees Celsius, which is sufficient for most hot tub installations. Consult the hot tub manufacturer's specifications to determine the actual amperage requirements. The number 10 copper conductor is suitable for grounding the hot tub circuit. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. The number 12 copper conductors are rated for 20 amps at 75 degrees Celsius, which is adequate for the 15 amp circuits in the shed. Use separate circuits for the washing machine and the general purpose receptacle to prevent overloading. Washing machines typically require a dedicated 20 amp circuit due to their high power consumption. General purpose receptacles can be on a 15 amp circuit, but avoid plugging in multiple hydro appliances at the same time. When pulling wires through the conduit, use a wire lubricant to reduce friction and prevent damage to the insulation. Use a wire pulling grip or fish tape to guide the wires through the conduit. Avoid pulling too many wires at once, as this can increase friction and make it difficult to pull the wires. Secure the conduit to the electrical boxes and panels using appropriate fittings. Use weatherproof fittings for outdoor connections to prevent moisture from entering the system. Install electrical boxes at each receptacle location in the shed. The boxes should be securely mounted to the wall studs or other structural members. Use weatherproof covers for outdoor receptacles to protect them from the elements. Connect the wires to the receptacles and switches in the shed, following the wiring diagram and local electrical codes. Ensure all connections are tight and secure. Test the receptacles and switches to ensure they are functioning correctly. Obtain the necessary electrical permits from the local authorities before starting any electrical work. The permit process ensures that the work is inspected and complies with all applicable codes and regulations. Contact the local building department to determine the specific permit requirements for your project. Schedule an inspection after completing the electrical work to ensure it meets all code requirements. Be prepared to provide documentation of the materials used and the wiring methods employed. Address any deficiencies identified by the inspector promptly to ensure the project is approved. Consider the voltage drop when running long circuits, such as the ones to the hot tub and shed. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause appliances to malfunction or not operate properly. Use a voltage drop calculator to determine the appropriate wire size for the circuit length and load. If the voltage drop is excessive, increase the wire size to reduce the resistance. Alternatively, consider using a higher voltage for the circuit, such as 240 volts, which will reduce the current and voltage drop. Ensure all electrical work complies with the latest edition of the National Electrical Code (NEC). The NEC is a comprehensive set of standards for electrical installations that is updated every 3 years. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Familiarize yourself with the relevant sections of the NEC before starting any electrical work. Consult with a qualified electrician if you have any questions or concerns about the electrical work. A qualified electrician has the knowledge and experience to ensure the work is done safely and correctly. They can also help you navigate the permit process and ensure the work complies with all applicable codes and regulations. Consider hiring a licensed electrical contractor to perform the electrical work. A licensed contractor is insured and bonded, which provides protection against liability in case of accidents or damages. They also have access to the necessary tools and equipment to complete the job efficiently and safely. When working with electricity, always take precautions to protect yourself from electrical shock. Wear rubber gloves and safety glasses to protect your hands and eyes. Use insulated tools to prevent contact with live wires. Never work on electrical circuits when they are wet or damp. Turn off the power at the breaker before working on any electrical circuits. Verify that the power is off using a non-contact voltage tester before proceeding with the work. Be aware of the location of underground utilities before digging. Call 811 before you dig to have the utilities marked. Avoid digging near underground utilities to prevent damage and potential hazards. When backfilling trenches, use clean fill material that is free of rocks and debris. Compact the fill material to prevent settling and damage to the conduit. Label all electrical panels and circuits clearly and accurately. This will help you and future homeowners identify the circuits and their corresponding loads. Create a wiring diagram of the electrical system and keep it in a safe place. This will be helpful for troubleshooting and future modifications. Inspect the electrical system regularly for any signs of damage or wear. Replace any damaged or worn components promptly to prevent potential hazards. Test the GFCI receptacles and breakers monthly to ensure they are functioning correctly. Replace any GFCI receptacles or breakers that failed to trip when tested. Be aware of the symptoms of electrical shock and know how to respond in an emergency. Call 911 immediately if someone has been electrocuted. Do not touch the person if they are still in contact with the electrical source. Turn off the power at the breaker before approaching the person. Perform CPR if the person is not breathing. Remember that electrical work can be dangerous. Take your time, follow all safety precautions, and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure that your hot tub and shed electrical wiring project is completed safely and correctly.